I'm Faith from the McAuliffe-Shepard Discovery Center, and thanks for joining me for today's virtual science demonstration on invisibility. Ooh. So I'm going to start off by showing you two beakers that I have here. Both beakers are full of liquid, and they have objects suspended in them. So I want you to take a look, and you can either say in your head or say out loud, how many objects do you see in each of these beakers? Shouldn't take very long to count, but just take a look and tell me or tell the person in the room with you there, how many objects do you see in each? I don't know about you, but I see one red object here, and I see one colorless object right here. So let's check our work. Over here on my left, I counted one colorless object, and there we go, we have one colorless object. Over here on my right, I counted one red object, and wait a minute, when I check my work, I see that there's in fact one red object and one colorless object. When it's in the liquid, I only see the red one. But I pull it out and I see that there's actually two objects. One of them is hidden, or it's invisible to us. So what the heck is going on here? Well, friends, it has to do with something called refractive index. So refractive index is a measure of how fast light can travel when it's moving through a material. And when something has a higher refractive index, the speed of light traveling through that material is slower. So that's called an inverse relationship. As the Ri goes up, the speed of light moving through it goes down, and vice versa. Now, if two materials have different refractive indexes and they're right next to each other, then as light moves from one material to the other, it's going to have to change speeds, right? Because the refractive index is a measure of how fast that light is moving. So different refractive indexes mean the two materials have different speeds of light traveling through them. The speed of light changes. It also means that some of that light is going to reflect like a mirror. It's going to reflect back, and some of it is going to refract or bend. So essentially the light is moving in a straight line, and then it refracts and it bends and goes that direction. So again, the relationship there is a balance in refractive indexes. Materials have really similar refractive indexes. The light doesn't change speed when it's moving through those two materials, and there's very little refraction and very little reflection. But if there's an imbalance, if one material has a really different refractive index from the material next to it, then the light is going to bend and it's going to change speeds, okay? So if we get back to our demonstration here, we remember that this is the beaker with no invisible objects in there. It's just one colorless object. This beaker is full of water. The one over here with the invisible object on it, this beaker is full of baby oil. And both of the colorless glass objects are made of borosilicate glass. So in the case of our tricky beaker here, the refractive index of the glass and the refractive index of the baby oil are pretty similar. So they're pretty balanced out, right? And as light is moving through the baby oil and through the colorless object, it doesn't change speeds very much, and it doesn't refract or reflect very much. That means there's nothing bouncing back to our eyes. So for all intents and purposes, it's invisible to us. We just can't see it. Now, in contrast, in this beaker over here, the one that acts a little more like you would expect it to, this is full of water, and again has that borosilicate glass object, and the water and the object have very different refractive indexes. So as the light is moving through the water and then hitting the glass object, it changes speeds, it reflects, and it refracts back to our eyes, and that's why we can see the object that is suspended there in the water. So I have one more thing to show you, and I'm going to have to move my camera. So while you can see me, I'm just going to say thank you very much for joining me today. And I hope you'll keep your eyes on our blog for more virtual science demonstrations in the near future. And now I'm going to move my camera over, and this is an illusion that you can all do yourselves at home really easily. That is just a regular glass of tap water and a drinking straw. And you see it, that if you look at it right at the level of the water, it appears as though the drinking straw is sort of split in two, almost like it's fractured or it's bent. We know it's not, it's just a regular straw, but it has that appearance. And that is because the air that is around the top portion of the straw up here and the water that's around the bottom portion, they have different refractive indexes. So that is causing that light as it moves through the air and through the water. It's changing speed, it's refracting, it's reflecting, and it creates an optical illusion that you can try yourselves at home. Thank you so much for joining me today, everyone, and be well.